along with my team at Arpit. We are presenting the face recognition with local binary pattern paper, which was presented at ECCV 2004, and it has won the prize in 2014. So now, how a facial recognition system can be built upon the local binary pattern. So before that, we will start with what is local binary pattern. So LBP is a simple yet very efficient texture operator which labels the pixel of an image by thresholding the neighborhood of each pixel and considers its result as a binary number. So using the LBP combined with histograms, we can represent the face image with a simple data vector. As LBP is a visual descriptor, it can also be used for face recognition tasks, as we will show in further steps. Last slide. Yeah. So face descriptor with local binary pattern. So if LBP contains two bitwise transition from a 0 to 1 or a vice versa, when binary string is circular, then we call it a uniform transition. So various papers in the past have shown in the experiment that with the use of structured images, uniform patterns accounted for somewhat less than 90% while using an 8-1 neighborhood pattern and 70% when using a 16-2 neighborhood pattern. Using the circular neighborhood and bilinear interpolation of the pixel values allow us any radius and number of pixels in the neighborhood. Yeah, so we will further define the histogram of the image as below. So here, histogram contains the information about the distribution of the local micro patterns such as edges, spots, and flat areas over the whole image. Yeah, moving to next. Yeah, continuing from the previous slide. So for a better representation of face, we need to retain majority of the spatial information with the histogram, which is calculated as below. So for the enhancement of the histogram, we further need to divide the images into M regions such as R0, R1, and then till Rm-1. And to resolve the problem with very few training phases, sample class we required, instead of more sophisticated classifiers, we can go for a nearest neighbor classifier. Yeah. Now, how LBP is applied in actual. So the first computational step of LBP is to create an intermediate image. So that will describe the original image in a better form. It will highlight the facial characteristics. So to do so, the algorithm uses a concept of sliding window based on the parameter radius and neighborhoods in a similar line of convolution. Yeah. So now we will define how we will actually achieve it. So suppose we have a facial image in a grayscale. So we can slice the part of this image as a window of 3 cross 3 pixels. So it can also be represented as a 3 cross 3 matrix where intensity of each pixel ranges from 0 to 255. So then we will take the central value of that matrix, which we will further use as a threshold. So now this new threshold will be used to define the new values from the eighth threshold. So how it will be defined is as follows. So we will set it as 1 if the neighborhood value is greater than or equal to the central threshold value, and 0 if the value is lesser than it. So now the matrix will contain only binary values. If we ignore the central value, we will need to concatenate each binary value from each position from the matrix line into a new binary value following either clockwise or anti-clockwise pattern. Yeah. So using that, we will convert this binary value into a decimal value, and then that value will be set as the central value of the matrix. So which is actually a pixel of the original image. So after we are done with all the pixels, we have a new image which represents the characteristics of the original image in a better way. So the LBP procedure was expanded to use different number of radius and neighbors, and it is called circular LBP. Yeah. So here we do the bilinear interpolation to accomplish this. So let's say if a data point falls between the pixel, the value of the four closest pixels 2 cross 2 is used to estimate the new data. So here you can see that for original image, we are dividing the faces into blocks, and then we are calculating the individual histograms. And using these individual histograms, we are then calculating the feature histogram, which defines and represents the image in a more better way. Yeah. So now I will hand over to Arpit for further discussions.
Hello everyone. So till now thanks Abhijit. Till now Abhijit discussed about this algorithm and introduction of our paper which we are presenting. So now I will talk about the experimental setup and results and all these. And so let's start with this. So uh, before starting the experimental setup, authors what did with the initial pre-processing. First, images will be pre-processed and used in such a way that only coordinates of eye will be there and all other non-facial area will be discarded. That way, this the pre-processed images will be further fed into the algorithm, which discussed by Abhijit, and the output distance matching matrix contain the distance between the pair of images. So in this way, distance matrix and the different settings of gallery probe image sets the system calculate ranks curve for the system. So further, we can calculate the preferred prescribed gallery and other set choosing random permutation. So as we can see in this system, that image files are actually pre-processed. As I talk about the initial experiment setup, this is the part of CSU face recognized system, and then pre-processed images are fed into the subset of algorithm, and then training data fed into the algorithm, experimental algorithm. Then further, this produces the distance matrix and gallery images, which I just talked about. So this all will be further passed to the NN classifier, and which produces the rank curve. So we will see further in how result will be generated with this all setup. So in CSU experiment, all the probe image set that were used in the FERT test, that all contains at most one image per person. So one image of heavy subject is selected to the gallery set, and another image to the probe set of for the permutation. So some of the parameters of this algorithm proposed in algorithm of LBB operator, these produces large amount of different labels. So we can make the histogram long, and that calculation can be done efficiently. For that parameters of division, there are some regions which are denoted as RGO2 IM1S1. That actually feature vector becomes in such a way that number of regions and BR in the LBP histogram and length. So that produces the histogram in such a way that we can get number of calculations, and so we can represent this in a number of features. Further, we will see how result can be produced by this paper. So they choose actually two different LBP windows for varying size. We will further see how this varying size will be actually calculated and give different results. So all these different varying for varying size, we calculate different distance matrix for different settings. So in this permutation tool, we calculate all the possibilities of outperforming with each other. So in next table, which is shown here, in this table, all the performances of the histogram will be there. So in this window, with different window sizes like 18 to 21, 21 to 25, and all these, we calculate how this probability of histogram and log likelihood with the histogram and chi-square calculation, and chi-square and probability of chi-square and log likelihood is represented in this way, and how this calculation is going on. So here we can see that from the result we observe that LBP representation is quite robust with respect to the selection of parameter. What parameter we selected, like chi-square statics measure we selected for this, and average number of labels per histogram is low, but log likelihood performs here better. From we can observe all these results from this table. So changes in the parameter may cause big differences in the length of feature vector. which is defined by this table, and overall performance is not necessarily affected significantly. So further, there are in CSU system there are two training sets. One is FERT and training, and one is CSU training. And all these trainings have different common different training set, and number of images are different. So we will test a whole this paper algorithm with this FERT standard and CSU standard. These sets are basically subsets of FE, FE, and DUB1 sets, as we can show in table 2. So the permutation tool was used to compare the weight computed from the different training set, and the weight obtained using the FERT standard set gave an average recognition rate of 8.0, and CUC standard set with 0.78, and the sub-FC set with 0.81. So we can say that pairwise comparison showed that the weight obtained with the subset set are likely to be better than others. So here we can actually see all the ranking with different methods. So here total five comparisons are done on the data sets, as we discussed in earlier slide. The first is LBP with weighted. So here weighted parameters are given, and LBP with non-weighted, PCA, and Bayesian map, and GB optimal. All these have performed different ranking with cumulative score. So this shown in the different in these graphs, that how this FERT said that mean recognition rate of permutation test with 95% of confidence interval. So now we'll talk about the advantage of LBP for face recognition. So here there are so many advantages of this LBP for recognition. The main is good performance and the grayscale changes in this LBP. So it's actually computationally simple and high discriminated power it has. So in LBP is one of the easiest face recognition algorithm known from very early time. It can represent local feature in the images, and local features, recognition of local features in the images are very important in terms of recognition. And it is possible to get great results mainly in control environment and robust against monotonic grayscale transformation. So we will now talk about what is the limitation of LBP in terms of face recognition. So the sizes of feature increases exponentially with the number of neighbor sizes. So in this way, if feature increases, then complexity of computation will be increased in terms of time and space. So that could be a problem if number of features will increase in a complex image. Structural information captured by this algorithm is very limited. So pixel differences can be used only to magnitude information is ignored. To produce longer histogram, which slow down the recognition speed, especially on large-scale face databases. So it can be implemented on smaller normal databases. Under some certain circumstances, they miss the local structure and they don't consider the effect of certain pixel. And the binary data produced by them are sensitive to noise. So further, after 2004 success of this, so many other papers came, and they actually talked about what the improvements of this LBP with face recognition. So mainly in CCBR conference, they actually talk about improved algorithm based on LBP for face recognition. And they propose the advancement over LBP as a middle box with multiple blocks. As we discussed, there were blocks, and they improved that blocks with some middle box and double cycle LBP descriptor. With this, they show that LBP can be more improved and can be a very great tool for recognition. And some papers also came later on after 2014. There was one paper on face recognition algorithm based on completed LBP, and there was another paper which talk about face recognition method based on CSLBP and DBN. Thank you so much. This is from our side.